Hello everyone. So we are discussing about the fourth model, that is about the timer and counter. So already we have discussed some of the things regarding this model, that is regarding the timer and counter. So as we know, there are two timers per counters we have on the microcontroller. So these timers or bar counters are of size 16-bit, which are there on microcontroller. They can be used for the timers or can be used for the counters. So let me once again just remind the things which are being discussed previously. So the 8051 has two timers per counter as it has been told. So the timer is meant for the delay time delay generation, and the time delay is already is prescribed, whereas the counter is meant for the externally count operation, and it is going to count the external events happening. Both the timers in timer 0 and timer 1 are 16 bits wide. So that's what we have discussed previously. So they are of size 16 bit. So to handle these timers, timer or the counter, we have a T mode register, and this T mode register is split up into two sections. So here as you can see, timer 0 and timer 1. So this is of size 8-bit, and here lower nimble can be configured with the timer 0, whereas you can configure higher nimble with the timer 1. So that's what we have discussed previously, and this is the how the different bits of the T mode we have, like a gate, C bar T, then M1, M0. So these gate represents where the simulation is given or the initiation is given externally or internally. So that will be decided by this gate, that is going to be internal simulation or the clock, or either it is going to be external simulation or the clock, which will make your timer or counter to work, will be decided by this gate. Then this C bar T represents whether you are going to work this particular timer as timer or this as going to be a counter. Then M1 and M2, M1 and M0 is going to be decided for the different modes, that is mode 0, mode 1, mode 2 and mode 3. So we are going to discuss in detail about these modes. So as it is been given like 13-bit timer mode, 16-bit timer mode, 8-bit auto reload mode and split timer mode. So we are going to discuss in detail in next slides. So first of all, we are going to take for the timer. So first thing, timer. So in case of this timer, it is timer has to set with the initial value. So whenever you are using this timer, the timer has to set with the initial value that will decide how much time delay you are going to generate. That will be decided first. Then start the timer and then count 8051 counts up. So always what will happen is when you are set the timer, then the 8051 is going to count up and it is going to generate the particular delay mentioned. Then in case of this one, this input from the internal system clock. So in case of the timer, we are going to use the input that is from the internal clock cycles, that is from the machine cycle. So whatever the input oscillator we have, that we are going to use in case of the timer. Then when the TRX register equal to 0, then 8051 sets a bit to denote timeout. So in this case, what will happen is we have a register called TCON. So within that we have TR0 and TR1. So that bits will decide whether the time delay is generated or not. So whenever it is set, so it is going to generate the time delay, and when it is going to be set, it is going to stop for the particular event. So this is how it's going to be done. Next is about the counter. So counter is going to, as we know, like counter is going to count the number of events so which are happening externally. So in this case, count the number of events, show the number of events on the register. So here in this case, as we know, like TH0 and TL0, which are meant for the timer 1, timer 0, and timer 1 TL1 and TH1 we have. So those 16-bit register together are going to decide the sides of the event happening. So external input from the T0 input pin for counter 0 and external input from T1 input pin for counter 1. So here in this case, what will happen is whenever you are using the counter 0 and counter 1, you need to get the external input signals, that is on the T0 and T1. So as we can see in case of the microcontroller, this pin diagram, we have T0 and T1 pin. So these two pins will be used for the configuration of the counter. So whenever you are getting the external event at these two pins, we are going to get the counter initialized or counter working. So next, so this is how we can see how actually the counter is counting the external events. So next is about the gate. So whatever I have mentioned here previously, this gate, so we are going to see some of the things regarding this gate. So what this gate is going to do and how the 0 and 1 bits are going to represent the different tasks. So here in this case, gate 0 will indicate so it is the internal control. So it is as if we are writing some software instructions, and that is going to handle your timer or counter. So the start and stop of the timer are controlled by the software. So that's what it is begun. Then how it is going to be done is set B TR0 and CLR TR0, or set B TR1 CLR TR1. So what is this set B? In the sense, it's a set bit TR0. So you can, in general, you can take this as a TRX. So it can be a TR0 or TR1. Okay. So this is going to set the time, your counter or the timer, and it's going to be clear the TR0, in the sense it is going to reset that, means you are going to stop it. Okay, so this is how using the internal software instruction you are going to handle your timer or the counter. Then gate is equal to 1. So in case of that one, what will happen is, when you are considering the gate is equal to 1, it is going to be using the external controls and external signals it is using. So that's what it is being given here, that hardware way of starting and stopping the timer by software and external source. So timer bar control is enabled only while the INT pin is high and the TR control pin is set. So definitely we need to control the TR pin, but here also you can see the TR pin is controlled using the software. Here also we need to control the TR pin using the hardware, and in this case it is done using the sum instruction, whereas in this case what it is happening is, you are using the INT pin, that is we have INT pin on our microcontroller, so that you can see here. So INT0 and INT1, so these two pins are any of the pins are going to be used for the external signal, so that you can handle the timer or the counter using the external what you can say, the signals or the external pulses. Next is about C bar T. So as we know, counter bar timer it is used for. So C bar T, in the sense you can set it either as a counter or you can set as a timer. So in the case of the timer, if you are using as a timer from the internal system clock, so that's what we have seen previously. So set for the counter for operation, so input from the TX input pin. Okay, so this is how the timer or the counter we are going to use. And these are the M1 and M0 sense. These are the different modes, like mode 0, mode 1, mode 2 and mode 3. So for mode 0 it is 13-bit timer. So 8-bit is there in THX and 5-bit is there in TLX. Okay, so it is together, it's going to form as 13-bit timer or the counter. Okay, whereas this one, in this case, as we discussed previously also, so this is together, it's going to for the 16-bit, and it is going to give you the execution of 2^16 events. So here we have the 8-bit auto reload mode, where you are going to reload the execution, and you can start once again. Okay, and here in this case, split timer mode, in the sense either you can use together as a 16-bit timer mode, or you can use one as an 8-bit and another as another 8-bit. Okay, so this is how. Okay, so in detail it has been explained here. In mode 0 what will happen, so you can see here TLX is loaded with 5 bits, THX is loaded with 8 bits, and TFX. So what is this TFX? In the sense is a overflow flag. So it's there in the control register, it is there in the TCON register, control register. So when it is high, then it is going to end the event. Okay, so similarly for mode 1, as we know, like it's a 16-bit mode, so it is going to execute until this TFX or overflow flag will get set. Okay, so similarly we have this mode 2 here. In this case, as we know, it is for the 8-bit auto reload mode. So we have certain value within the THX, so when it reaches the particular event, again it will be auto reloaded. So when we will come to know that it is reached to the particular event, it's in the sense whenever the TFX bit is TFX bit is high, that time you will come to know that this particular event has reached the particular set value and it is going to auto reload. So similarly in mode 3, it can be a 16 bit or it can be two different 8 bit which are handled using the timer clock or the oscillator frequency. Okay, 12 that's how it's going to be worked as. Let us consider an example. So we are taking an example where we are designing a timer and that is in mode 1. So for this, let us consider time is 0 and as an example. So we are designing a timer 0. So that is in a mode 1, that is in a 16-bit timer mode. So what will happen is TH0, TL0 is incremented continuously when TR0 is set. So as we know, so when TR0 is set, it will be start incrementing, or it will be start counting. So when until the TR0 is reset or it is cleared, it will be go on counting. Okay, then timer works with the internal system clock. Okay, so as we know, like timer will be designed such that it will be only working in a internal system clock, whereas counter will work on the external clocks, that is on T0 and T1. Okay, so when the timer reaches its maximum FFH, so it rolls over to 000 and TF0 is 0. So when if you are keep on counting from lower value to this maximum FFH, right, since it is a 16-bit what you can say is counting, so that time if it rolls over to 0000 again, then TF0, that is in the tick on register, TF0 will be raised. Okay, and you will become to know that it is reset again, the timer is reset. Programmer should check TF0 and stop the timer. Okay, so once you check this one TF0, then you will come to know that it has reached to the maximum and you can stop it. Okay, and how to stop it? You just have to make this TR0 clear. Okay, then okay, so we are going to see what all the instruction we need to write for this example. Okay, so what it is being given is we need to take as timer mode 1. Okay, so this timer is timer 0 and it is in a mode 1. So here move T mode comma as 0 and H. Okay, so this is how we are going to make this selecting the T mode will be selecting the timer 0. Okay, and it is making the timer in a mode 1, right? So then set the original value to TH0 and TL0. So what we are making is we are setting the value as FFFCH. Okay, so from this FFFCH, this timer has to count up to FFFFH and it has to stop. Okay, so and before that we know, like we are going to observe this TF0, so better to clear this TF0 flag. So we are going to clear this TF0 flag, then set bit TR0. So set bit TR0 in the sense, once you set this TR0, you are going to start the execution, right? So you can see here the 805 start the count by incrementing the TH0 and TL0. So how it is going to increment the count? FFFCH, FFFDH, FEFF. So once it rolled over to 000H, so TF0 will be high, right? So that's what it is happened. So up to this it is 0, and when it has reached 00, it will become 1, right? So TF1 is high now. So once it has reached TF1 is high, so that time we need to clear the TR register, right? So that's what it has done in this case. So to observe the continuous TF0 bit, we are using this instruction again, colon JNB TF0 comma again. In the sense, it will be continuously there in this loop, so that until and unless it is there, JNB in the sense jump not bit. So it is there 0 bit 0, this TF0 is 0, this will be there in loop. Once it is 1, it is going to come out of this loop and it is going to execute the next instruction. So what will be the next instruction? So since it is going to be 1, in the sense we need to clear the TR0 and we need to stop the execution. Okay, so that's what the clear TR0 for the stop to stop the process, and again to make some other execution we need to clear the TF0. Okay, so next is about So we can see the TCON register. So as we already discussed regarding this TF and TR, so this TF0 and TF1, TR0 and TR1, as you can see, so this is meant for the timer or the counter zeroth, and this is meant for the timer or counter first. Okay, so as we know, zeroth and first timer or counter, to handle that one we have these 4 bits available, and whereas this to handle the external interrupts, we are having these 4 bits available. Okay, so this is about the TCON register, right? So this is a 8-bit register. So as we know, like TF is meant for flag which will indicate whether the particular event has happened, and it will be affected, or it is going to change. This is going to change its position based upon the this bit, that is TR1 TR0 bit. Okay, so next is about, so here in case of this one you can see the TR. So what is this TR? In the sense is a timer run control bit, right? So as we know, like when TR0 is TR is equal to 0, that time it is going to be stop, and when it is 1, it is going to be start, right? So this is about these bits, so it has to be either 0 or 1. So based upon that, based upon this thing, either it is going to be going to start or stop, right? So that's what it is mentioned in this case. So similar timer flag or the control flag, so it is going to indicate whether the particular event has reached the maximum value, right? So that's what it has been given here. So in this case, like as we already seen, like TF0 is 0 and TF is 0 or TF is 1. Based upon this, the event is going to happen, or whether it is reached or not reached, with it will be decided by this TF flag. So except this, if we enable interrupt, that is when the in the case of the interrupts, so when this TF is 1, so it is going to trigger the interrupt service routines, right? So that's what about the TCON register. So next is about how we are going to declare or write the instructions. Okay, so to initialize the timer or the counter, so that's some of the instructions given here. So we know, like, to initialize the timer, we need to initialize this TR0, set the TR0 or clear the TR0, set the TF0 or clear the TF0. So it is in case of a timer or the counter 0. So how it can be done is, it is just as if set B TCON 4th bit. Okay, so what is this set B TCON 4? In the sense, we have the 4th bit. Okay, so where is that 4th bit? So here it is a TCON register, you can see. So what we are doing is, we are making the 0th bit 4th bit of the TCON register, so that we are making this bit, right? So this bit we are making high, so that we are going to set the TR0. So similarly, if you want to clear it, you need to clear this bit to 0. So similarly, if you want to access this bit, that is TCON 5 bit, that is this bit, right? So 0th, 1st, 2nd, 3rd, 4th bit, okay, 5th, 6th and 7th bit, right? So total we have 8 bit. So this is the TCON 4th bit, and this is the TCON 5th bit. So similarly, if you want to access the time for timer 1, so these bits can be TCON 6 and TCON 7. So TCON 6 is this bit and TCON 7 is this bit. Okay, so you can just vary the bits, so that you can set or reset the TR registers as well as the TF flags, right? So next we are going to see some of the examples. Simple application using ports and timers. So here we can see, using port by simple program, you can generate a square wave of any duty cycle. That's what here they have given the description. So how it will be done is, so set B and clear B, they are using the instruction. So set B in the sense, it is going to take you a high pulse, and clear B in the sense, it is going to give you a low pulse. Okay, so in between you just have to give a delay. You just have to call a delay, and it is going to, when you call the same delay, it is going to give the 50% duty cycle. Okay, set B P1.0. so P1.0 pin they are using, and same pin they are clearing it. Okay, so it is going to generate the what you can say, the pulse square wave it is generating, and it is of the same what you can say, duty cycle, right? So s jump here in the sense is going to continuously repeat the same thing. Okay, so if you want to vary the duty cycle, you just have to vary this delay, or you can increase or decrease the delay so that the width can be increased or decreased, right? So in the next example you can see, so here they are generating the 60%, 66% duty cycle. So this is based upon the delay only. So either you can call delay for 2 times here and 1 time here, or you can use delay 1 here and delay 2 here by writing the 2 different delays. So you can write in any way. So what they have done here is set b p1.0 and clear b p1.0. so between set b and clear b they have kept the 2 times delay, whereas in case of after the clear p1.0 they have only called 1 time delay, so that there is a difference between the delay after the positive pulse and there is delay after the negative pulse is varying, right? So previously it is same, okay, only once they have called, but here in this case it is here twice and it is once here. Okay, so obviously this time delay is going to increase, right? So this is how we are going to generate the different types of the waveforms. So here in this case you can see square wave generation using a timer. So it is for the 50% duty cycle on p1.5. so here in this case so they have written the program where square wave of 50% duty cycle is generated on port p1.5 and it is using the timer 0. So we are going to see how it will be done. So here in this case you can see move t mode 01h. So t mode in the sense we are using the timer where it is the timer 0 we are using, and 01 in the sense obviously we are using the mode 1. So mode 1 is what? Mode 1 is a 16-bit mode where th0 and tl0 are loaded with some value. So we are using here tl0 and th0. So tl0 is loaded with the f2 and th0 is loaded with ff. So it is together going to have the value ff f2h, right? So this value it is loaded, right? So up to this event there will be a the increment of the value. So up to that ff f2h it is going to increment, right? So this is how it is going to work. So cpl p1.5, so cpl p1.5 in the sense that there is a complement of the p1.5 bit, in the sense if it is 0 it will be converted to 1, continuously it will be changed, and you are going to call a delay. So you may be asking like where the timer is used. So here in this case delay, you can see delay program set p tr0. So already we have discussed regarding the timer action where when you set the tr0 it is going to start the timer, and when you clear the tr0 it is going to end the timer. Okay, so it is observing the tf flag. So tf0 flag is observing it. If it is continuously 0 it is there in a loop. Once it is 1 it is going to come out of the loop and it is going to make tr0 clear and tf0 clear, and it is going to ret in the sense return. So it is going to execute the next instruction where it is been paused. So where it is been paused is it is been paused this at this instruction s jump here. So again it is going to repeat the whole. So this is some of the examples on timer on the counter. So we are going to discuss the next thing in next video. Thank you.